In this lecture, Hello everyone and welcome. In this lecture, we'll quickly see dist plots. As usual, we start by importing the modules and libraries that we need. I copied this from our previous lecture. So we'll be using NumPy's randn method for generating a list of random numbers. So let's start by creating those. So np.random, the method name is randn, and let's create a list of 150 normally distributed random numbers. Okay, and let's save this in a variable called number. And what we'll do is Seaborn has a method known as distplot. Then we'll pass the randomly generated numbers. So distplots by default have histograms and a kernel density estimate. Let me run it and show you. So this is a default graph for distplots. We have a histogram and a KDE. Okay, and we can pass the color attribute to change the color of our distplot. So we can set the color to be, let's say, red. We can do that, or any other color that you want. We can also label our x-axis. Let's see how we can do that. Let's first create a series object by using Pandas series method, and then we'll pass our number here, a list of randomly generated numbers here. So we'll pass num and then name for our series. Let's name it what? Let's say variable x or whatever. And let's save this in another variable. Let's call it labeled distplot. So label dist. Now we can call the distplot method and then pass our label dist object. That way the x-axis will have a label, variable x. We can also make our plots appear on the y-axis by passing the vertical attribute. Let's do that. So we have, our name is label dist, sns that distplot, and then we'll pass our label dist object, and then we'll pass the vertical attribute and set it to be equal to true. If you run it, now the plot appears, the dist plot appears on the y-axis. Let's copy this and paste it here. If we want to change the default color of blue, we can pass the color attribute and set it to, let's say, red. Run it. Now it's red. You can pass any color that you want. Again, by default we have histogram and a KDE. And if we don't want to see the histogram, we can pass another attribute known as hist and set it to be equal to false. Let's see how to do that. So sns.distplot, and then we pass our label dist object, and then pass the hist attribute and set it to be equal to false, and run it. Now we only have a KDE. So this is similar to a univariate KDE plot. Again, instead of a histogram, we can pass the reg attribute and set it to be equal to true. So we can set reg is equal to true. So now instead of a histogram, we'll see a reg plot for each of our data set, for each of our data point. So that's a reg plot with KDE for our dist plot. And we can change the color by passing the color attribute again. Color is equal to, let's say, green, run it. Now we have green for our dist plots. Okay, that's what I have for this lecture. Just to summarize, we looked at dist plots in this lecture, and we saw that by default a dist plot has histogram and KDE, and we can change the default histogram to, let's say, a reg by passing the reg attribute, or we can simply set it to be false by passing the hist attribute. And if we want to make the dist plot appear on the y-axis, we can pass the vertical attribute and set it to true. Thank you, everyone. Hello everyone, and welcome to the lecture on KDE plots, kernel density estimation plots. KDEs are used to find out the probability density function of a given dataset. I won't go into the details of that, but you can read more about it on Wikipedia. We'll start by importing the libraries and modules that we need. I copied this from our previous lecture. Import Pandas, NumPy, Seaborn, and Matplotlib's pyplot, and the special function Matplotlib inline allows our plots to appear on Jupyter Notebook. What we'll do for this lecture is use one of NumPy's method known as the multivariate normal method, and that method will allow us to come up with a dataset that's appropriate for KDE plots. Okay, let's start by defining two variables that we'll need for that method, and we'll save it in variables known as mean and covariance. And let's set the mean to be 0, 0, and for covariance we'll pass a list of two values, let's say 0.2 and 0, and for our second element we can use, let's say, 0 and 3. We can adjust this once we see the KDE plots. Now we can use the method that I mentioned. So np.random.multivariate underscore normal, and then we'll pass the mean and covariance, and let's pass a size of maybe 40. We can adjust that later. And then we'll call the transpose method on it. So you don't have to know what this method does, but it's just the easiest way to create some dataset for our KDE plots. And we'll save this in two variables. Let's call it x-axis and y-axis. Okay. Now that we have that, we can proceed to our KDE plot. So we'll use Seaborn's SNS. We'll call the KDE plot. Seaborn has a method known as KDE plot. So we call that, and then we'll pass, let's see, the kernel density estimate of one of our variables, x-axis. So let's pass x-axis and then run it. So this is the KDE plot, kernel density estimation plot, for our x-axis, which is one of our variables. Okay, we have two variables. We call them x-axis and y-axis. So this is a KDE plot for one of our variables. Similarly, we can call the KDE plot and then pass our second variable, y-axis, and that's the KDE plot for our y-axis. Okay, we can also shade this part under the graph by passing an attribute known as shade. Let's do that. So we can say SNS.KDE plot, then pass x-axis and our attribute shade, and then set it to true. We can do that, and if you run it, Now we have a blue shade underneath. You can also change the color of the shade by passing the color attribute or parameter. So it says, we can say color is equal to, let's see, green maybe. And now we have a green shade. You can pass whatever color you want. That's for our x-axis. We can do the same for our y-axis, sns.kde plot, and then we'll pass our y-axis variable, and then we'll set the shade to be true, and then color is equal to, let's say, purple, and we have a purple shade. Okay, now let's see a KDE plot of both of the variables. Okay, so sns.kde plot, and then we simply pass the two variables, x-axis and y-axis. This is called a KDE plot for two variables, or bivariate KDE. Bivariate means two variables. Okay, let's run it. So that's a KDE plot for two variables. We have contour lines, right? Similar to what we did for our single variables here, or univariates, we can also pass the shade parameter and shade these contours. So let's do that. sns.kde plot, and then we pass our bivariates, x-axis and y-axis, and then we can set the shade to be equal to true. Run it. Now our contour lines have shades, and if we want to change the color of this shades for our contour lines, we can pass the color map attribute, and we can also change the number of these contour lines. We can have more contour lines if we want by passing another attribute known as number of levels, or n levels. Let's do that. So sns.kde plot, we have our x-axis and y-axis variables. We can pass, one is the color map, cmap. Let's pass a color map of maybe RDBU. Let's see. So RDBU, red, blue color, or you can use some other color maps. If I remember correctly, we can use a color map known as HUSL or BlueSty. We can use all those sorts of color maps. Okay, let me copy this and see some other color maps. RDBU, there's one known as BlueSty, and so on. In the previous lecture we have seen HUSL. So here it says color map HUSL is not recognized. Okay, possible values are here. You have a list of various color maps, so you can try it out. Okay, let's see, cool warm. I'll just show you cool warm, and run it. So that's what it looks like. You can use any of those possible values. Okay, the next thing we can do is change the number of contour lines by passing the number of levels attribute. So here we have sns.kde plot. We pass our x-axis, y-axis, and then we have our color map, and the attribute is number of levels, so n levels, and we can set it to be whatever number we want for our contour lines. Let's say 18. Let's try that out. So we have, if you count this, it's 18. I'm not going to count it, but 18. You can change this to, let's see, let's make it more contour lines. Let's say 35 maybe, and let's change the color to cool warm, and run it. So right here it says 35. we have more contour lines. So similar to the number of contour lines for our bivariate KDE plots, there's also another attribute known as bandwidth. By passing that bandwidth attribute, we can make the single variate KDE plot narrower or wider. Let's see an example of that. So we have sns.kde plot, and then we'll pass, let's see, y-axis, and then for our bandwidth, it's BW, stands for bandwidth, and then let's set it to be equal to, let's try 1.5 and run it. So it looks like it's wider compared to the normal KDE plot, sns.kde plot, and let's see the normal bivariate KDE plot without passing the bandwidth attribute. See, that's the normal, and this looks a bit wider. And you can change the value of the bandwidth to different values. Let's pass, instead of 1.5, let's pass 0.3 and see the difference. Now you have that. So you can play around and pass different values. Let's say 0.1. You can pass different values.